When we want to talk about continuity of functions, it's important to discuss discontinuities and whether or not they're kind of catastrophic or not. This happens a lot when we're dealing with data in the real world or modeling functions. We want to be able, or modeling phenomena with functions, we want to be able to determine if we have something that's pretty close to a continuous function or if we have something that's not. So when we talk about that, we say that if a function is continuous everywhere on an open interval, so we have some AB and we say it's continuous everywhere on this open interval except at some point C. So somewhere in this interval there's a point that's a problem for us. Well, we have two cases when that happens. The first one is that we can say that that point is what's called a removable discontinuity. And we'll get to that in a second. And the second one is that it's a non-removable, which makes sense. It either is removable or it isn't. In the case of a removable discontinuity, it's one of these types of cases. So in this one, I have a function, but it's not defined at the point. It just doesn't exist there. The second one is that a function exists at the point, but it doesn't agree with the limit. So if you were tracking the function normally, it doesn't agree with what you would think would be the behavior. And so the trick, or the way around this, is to define a second function. If this is the graph of f in either one of these cases, then I can define some sort of g function. I can say, well, g of x is continuous. Well, it's equal to f everywhere except at that point. And instead of being equal to whatever f is, whether it exists at all, what I'm going to do is, whatever that limit is, whatever I think it looks like it should be going to, that's what I'm going to say it's going to. So I'm really constructing a function from these pieces. And if you do that, then what you have is simply a removable discontinuity. All it says is, look, I got one point. If I just fill in that hole, I have a continuous function, I'm good to go. However, in the non-removable discontinuity, we have a problem. There's no way to redefine this that makes it make sense. Because even if I redefine this point, or I redefine this point, there's still this huge gap between this function and that function. So there's no way to fix that. So generally speaking, the easy way to recognize this when you have graphs is if you have that solid break, that discontinuous break, versus a missing point. These look more like missing points, and these look like separate graphs. So in this particular case, this is non-removable, and there's not a lot you can do with it. You just have to kind of work around it.